Welcome everyone to the first in a series of videos all about switch assessment. Today we're going to be specifically talking about how we determine an optimal switch site, and as a part of a series we're going to really dig down deep into switch sites as well as switch types. My name is Michelle Lange. I'm an occupational therapist in the Denver, Colorado area, and I've been working in assistive technology for a lot of years now, and I do quite a bit of switch access because I work with a number of clients for whom another method of access, such as direct, eye gaze, mouse, is not effective for them, either because of motor and or visual issues. And so sometimes we need to identify an appropriate switch site and type, or a multiple amount of switch types and sites, in order for this person to access their assistive technology, such as a communication device or a power wheelchair. So let's jump in. So this is what we'll be covering in this series. We're going to talk specifically in this video about how we determine an optimal switch site, that assessment. But then we're going to jump into some switch site options following a hierarchy and talk about some of the criteria of how we would decide where to place a switch, and that will be divided into 3 videos, followed by videos that review some of the common switch types on the market and the clinical indicators for each of those. Something that's important when looking at switch access is to keep in mind that depending on what we're accessing, we may use the switch or require our client to use the switch in a very different way. So for example, to operate a power wheelchair switch toy, the client needs to activate a switch and sustain activation for as long as they want that switch activated device, like a switch toy, to continue operating, or as long as they want to move the power wheelchair in a certain direction. Now there are some ways around that using other technologies like switch latch and timers or power links, or even a latch feature on a power wheelchair. But in general, it requires sustained switch activation, and in the case of power wheelchairs, very quick release, because that's how the client is going to stop. For communication devices or other devices requiring scanning, now the client requires almost the opposite motor pattern, where the client is going to activate a switch to start the scan, depending on the type of scan, wait some more, anticipate their choice coming up, and still activate that switch accurately to make a selection. Release is not usually a very time-dependent thing. So as we go through this series, I really want this to be practical for you. So think about a client you're working with. As we go through this information, think about perhaps where you might try a switch for access to assistive technology, and what specific type of switch or switches that you want to try. I hope it works for you. Keep that client in mind, or clients, as we're going through this information. So let's talk about what constitutes an ideal switch site. Just what is an ideal switch site? Well, ideally, and we might just be approaching ideal, we may not be able to actually get there, we're looking for a small movement, not a really huge movement, as small a movement as possible. We want that movement to be isolated, volitional, with controlled activation, sustained pressure if needed by the technology, and controlled release, particularly again for power wheelchairs. So let's talk about each of these in more detail. A small movement. Now some of our clients, particularly clients who have a lot of increased muscle tone and who may also have primitive reflexes, particularly that ATNR, that asymmetrical tonic neck reflex. When that client wants to use their hand, for example, they may turn their head to the side in order to extend the arm on the face side, and then bring it around in front of them and clobber a switch. The problem is that's a really big movement, and we certainly see clients who do this. It takes a long time. That slows down a scan. It takes a lot of effort, so the client may fatigue sooner. It also takes their eyes off the task. Now they're looking to the side instead of forward. So we want to avoid the big wind up and find as small a movement as possible, because that's going to increase speed, particularly speed of scanning, but speed of switch access. And it can often increase accuracy in scanning as well. I'm less likely to miss my target. For example, we have Lauren here. Now, Lauren, when she was younger, was able to use her hand to reach out and directly access the display on her communication device. But as she got older and hit her early teens, it was getting harder and harder, and she was using a very large movement, and it was wearing her out. So we placed a switch by the side of her head where she could very readily hit this switch using a very small movement and while maintaining visual contact with the display. We literally compared how long it took her to use direct access and switch access to complete several sentences, and she decided that switch access, even though it seems slower since she had to wait for the scan, was actually faster and more accurate for her. Also, an ideal switch site is going to use an isolated movement. Well, what does that mean? That means that I can reach out with wherever the switch happens to be with that body part and access the switch with a discrete movement. I'm not pulling in other movements. One of my favorite descriptors of this was way back in occupational therapy school. One of my teachers explained overflow like this. She said, think about someone putting on mascara. Oftentimes that person will open their mouth wide while they're putting on mascara. Can we put on mascara without opening our mouth wide? Yes. But our body's trying to help open our eye wide. And some of our clients, when they're trying to access a switch, are going to use other parts of their body to help out. The problem is that gets very fatiguing, and that movement doesn't have as good a control. An example of this was my friend Travis. When Travis was first learning how to drive a power wheelchair, he was using switches up by his head. But we noted that every time he turned to hit one of the switches by the side of his head, his hip was rotating forward. There was a little bit of that residual reflexive influence, that AT&R again. So we fiddled around with the position of the switches a little bit until we did not see that overflow, until we had a discrete isolated movement. We also need this movement to be volitional. Now this might seem to be fairly obvious, but some of our clients have quite a bit of movement, and sometimes that movement looks volitional, but it may not always be, or it may never be volitional. So we have to seek out movement that is. So we don't want this to be part of a pattern of movement. Some of our clients work within large patterns of movement and again have difficulty isolating movement. We don't want it to be part of a reflexive movement that might allow someone to get to the switch, but it's probably going to be difficult to keep repeating that movement and to release the switch. And of course, under voluntary control. My favorite example of this was a middle schooler I worked with named Sarah. Sarah was really boy crazy, and her team had taken some switches and placed them on the end of her tray. And when she got excited, her arms would extend in front of her and adduct with great force, and that's where the switches were. So she would run into those switches and drive down the hall. The problem was when she saw those cute boys, she got really excited, and she would extend with great force and have difficulty releasing. So she would fly right by the boys and crash into things. What we did instead was to place those same switches behind her elbows. This allowed her to, with better control, volitional control, pull her arm back, retract it back into the switch to move forward. When she saw a cute boy, her tone would pull her arms forward, and she could stop and chat with him for a little bit. Took her longer to get to math class, but she stopped crashing into things. An ideal switch site also uses controlled activation, where we reach out and actually activate the switch. This requires activation travel. I have to reach to the switch, and pressure if this is a mechanical switch. Now, electrical switches do not require force, and we'll be talking about that later in this series of videos. I'll give you an example. Brandon has muscular dystrophy, and he was having more and more difficulty using a standard joystick on his chair. So eventually he started using switches that were very light touch. They were midline to him and close into his body because that's where he had the most control. So the placement became very important and the type of switch site to allow him to have adequate activation pressure. If the switches were not in this location, even if he could reach them, he didn't have enough pressure to activate them. So there's a lot that goes into choosing the correct switch site and type. Speed is also a consideration. We want our client to be able to readily get to the switch and it not to take a long time, or this task will become very frustrating for them, frustrating for others. It will slow down their scanning speed. And then finally we have accuracy. Accuracy is also very, very important. For example, here in this picture we have a young man named Spencer, and you can see he has a lot of flexion in his arms. Well, in his previous seeing system, his arms were flexed at a much higher height. They were practically at his shoulder level, his fists were. And that's where the switch happened to be, was above that hand. But his control was difficult. His speed was slow, his accuracy was not very good. We played around with his positioning. We actually ultimately opened up his seat to back angle and his arms came down. It reduced the amount of tone in his upper extremities, and as a result he was able to still use a switch over his hand but with increased speed and accuracy. If this person is using a power wheelchair or again say a switch toy, they're going to need sustained activation pressure, and this can be easy for some clients, difficult for others. For people who might fatigue easily or have muscle weakness, this can be challenging. In Julian's case, and you can see his hand pictured here, he has muscle weakness due to spinal muscular atrophy type 1, SMA. So he has very small activation travel and force. So we place something called a fiber optic switch, which again we'll talk about later in this series, right by his thumb. All he had to do was wiggle his thumb over this location and it would activate the switch. No force was required, as this is an electrical switch, and a very small distance of travel was required. This allowed us to accommodate his muscle weakness as well as lack of endurance. And again, particularly in power mobility, a controlled release is important because that's how we stop this power wheelchair and avoid collisions. So timing of this release is important. Consistency of release, that I can release no matter what, and ability to release under stress, and this is quite important. This young lady here, Amy, is trying some switches out during an assessment. So we have all sorts of switches all over on some temporary switch mounts. We were trying some new locations because Amy drove with a head array. She had proximity switches built into her head support on either side of her head and behind her head. And she was a very good driver until the fire alarm went off at school one day. That startled her. It set off her tone. Her head collided with the back of the head support as she extended, and she went straight down that hallway until she crashed at the end. The school was very concerned. She was scared to death, and we knew we needed to move that switch from the back of her head to somewhere else. Now, most of the time, she was a fantastic driver, but we needed to make sure she could release even under stressful circumstances, and she demonstrated that that wasn't always the case due to her tone. So we needed to move things around. So how does this apply to the classroom setting? Well, I know a lot of you are working in a school setting. If the client doesn't have independent switch access, maybe someone's grabbing their hand and helping them hit a switch. If they don't have that independent switch access, it's difficult for everyone on that team to really accept that what the student's doing, that they're really doing by themselves, right? It's easy to assume that that person helping them out is actually doing the work. So this independent control becomes very, very important. The optimal switch location can make the difference between dependent assisted or truly independent switch access. So location is so important. So is the type of switch, but location is really where we start. The goal is automaticity. That way the student can focus on what they're doing and not how they're doing it. Think about driving in your car. A ball bounces across the street, your foot's on the brake. You don't have to think about where your brake is, thank goodness, or you might run into that child who's running behind the ball. You just hit the switch, you hit the brake pedal, right? We want our clients to not think about how do I hit the switch, where is the switch. We want them to think about where they want to drive or what they want to say. That requires automaticity, that requires lots and lots of practice with switch access. So no matter where the switch is located, it can be used to access technology for education and communication. So thank you very much for joining us for this first of our webinar series on, or video series on switch access. And here is my contact information if you have any questions. Thanks very much.
Thank you for watching this webinar. For more information on the ATP Education Program, please visit our website at atp.nebraska.gov or email us at atp.education@nebraska.gov.